This is an abacus. Now, I don't know much about it, but the little I do know makes me want to spend time talking about place value. It's an overlooked and underappreciated aspect of math fluency. Mastering place value is an integral part of arithmetic, multi-digit operations, decimals, and fractions. Studying place value, though, can lead into a deep dive of more fascinating aspects of mathematics, things like number sense, different base systems, and even ancient civilizations. Yes, most of whom used number systems that were not like ours, base 10, and that makes for fantastic math studies. Computers use a base 2 or binary number system, and following number systems require knowledge of those systems' place value. And for now, we'll stick to our base 10 number system. See, 10 fingers, base 10. It'll work. You see this symbol? It seems pretty simple, right? What do you think about, though, when you see that symbol? Right, even though it looks like some kind of boat sail or a lopsided field goal post, we recognize it as a number that we call 4, and that number has a value which is this many. It's an amount. And a symbol that does all that and means all that is called a digit. And we have our digits, right, 0 through 9, each one representing a value or an amount. And we need to distinguish between the digit and the amounts they represent. Remember, all numbers with digits represent a value, although not all values can be represented by numbers with digits. Think pi. And understand that we do not have a single digit to represent this many. That's why we call it a base 10 number system. It's efficient because it's based on our fingers, much like the base 2 system is efficient for computer processors who can work rapidly with zeros and ones. And so we have our place value based on tens, beginning with the ones place and then multiplying by 10 for each additional place. And base 2 works the same way, the ones place, and then multiplying by 2 for each additional place, right? They have the ones place, the twos place, the fours place, the eights place, etc. Fortunately and efficiently for the way our digits work, it just means for us that we can just keep plopping zeros down for each additional place. Working with other number systems and our digits, not so simple. It's kind of a brain stretch. So our places, we have the ones, the tens, the hundreds, the thousands, etc. The key to mastery of these places begins with understanding this number. It's made up of 2 digits and 2 places. And let that sink in because that's key. There's a 1 digit in the tens place and a 0 digit in the ones place. So it's 110 and no ones. But it's also 10 ones. Pause on that because that is some complicated stuff, right? Who would thought that 10 could be so complicated? So this number, it represents a lot of something, right? Picture 356 things, like puppies, right? This number is made up of 3 hundreds, 5 tens, and 6 ones. It's also made up of 35 tens and 6 ones, or could also be made up of 356 ones. All numbers can use place value this way, and all multi-digit operations use this concept in their algorithms for like subtraction or multiplication. Hopefully you recognize that our default place of understanding is the ones place, right? We do usually recognize this as 356, which means 356 ones. Remember the importance of units of measure. Here's a brain stretch. If you add 6 ones and 7 ones, you get 3 ones. Well, 110 and 3 ones. But you see how messy this can get, right? Remember not to take what you think you know for granted. So now we can get how place value works for big numbers, but what about small numbers? You know, numbers smaller than 1. And no, I'm not talking about negative numbers, but good thinking. They have place value as well, but instead of multiplying by 10 for each place, we divide by 10 for each place. And we still start with the ones place, we just need to incorporate this symbol called the decimal, which means tenth, and then plopping zeros down between the decimal and the digit. The ones, the tenths, the hundredths, the thousandths, etc. Consider this. It's the digit 5 in the tenths place, so we call it 5/10. But how it came to be is all in the reading of it and understanding decimals. It's 5 ones, but counting 5 after those ones are separated into 10 equal-sized pieces. 5/10. 5/10. This is the digit 4, a 4 in the tenths place. 4 ones, but counting 4 after those ones are separated into 10 equal pieces. 4/10. 4/10. I just taught you division. So this number, it's a 5 in the tenths place and a 4 in the hundredths place. What's interesting here is that it's the same thing as 54 in the hundredths place. So it's 54 ones, but counting those ones after they are separated into 100 equal-sized pieces. 54 hundredths. It's complicated, I know. And this is why mastering place value is not only important, it's very challenging. Don't underestimate it. Play around with it and practice with it as much as you can. To wrap up, I want to go back to where we began, 4. That simple little digit. On the abacus, it could be this, it could be this, it could be this. It all depends on how you set your place value, which is one of the things that the abacus can do. And that simple little digit has place values all around it in both directions infinitely. Wrap your head around this. That's this many. Be patient and be impressed.